Good morning, everyone, and welcome to our laundry room this week. Today we have Greg Wojcinski with AHAM. Greg, I hope I said your last name right.
You got it.
Awesome.
So really appreciate the invitation to speak to you all. I attended ASTI for the first time this past session and was so impressed with all the knowledge you all had. You all educated me as well as hoping to educate you all. So I'm hoping for that collaboration to continue here. And if you missed it previously, I'm going to send all of these materials, my slides and background materials to UASA to make available to you all. So you don't have to take notes if you don't want to. But we'll get right into the subject matter. Today's topic is nuisance tripping on home appliances. We're going to focus more on GFCIs than AFCIs, and we'll get into exactly what that means in a second. So just a little bit of background on the company, the organization I work for. AHAM stands for Association of Home Appliance Manufacturers. So just like UASA is an association of appliance service contractors or appliance service individuals, AHAM is an association of home appliance manufacturers, home appliance companies. So a lot of the major brands are members of AHAM, folks that you all probably work with: Whirlpool, Samsung, Electrolux. We also represent portable appliance manufacturers, folks like Dyson or Shark Ninja or Bissell as well. So what are we going to talk about today? We're going to talk about what is a GFCI. You can't talk about GFCIs without talking about electrical codes. So we'll talk about electrical codes. We'll talk about what is GFCI nuisance tripping and why is it happening. And then we'll spend most of today's talk on nuisance tripping resolution. How can you help fix nuisance tripping? And then a little bit at the end, we'll talk about AFCIs. So that's arc fault circuit interrupters, and we'll just touch on that at the end if there's some time. So what is a GFCI? A GFCI is a ground fault circuit interrupter. It's sometimes referred to as a GFI. A GFCI and a GFI are the exact same thing, just a different name. And their intent is to provide shock protection. So they function to de-energize a circuit when current to ground exceeds some predetermined value. And we'll get into exactly what that means on the next couple slides. GFCIs are found in 3 different types of constructions: a GFCI receptacle, a GFCI circuit breaker, and a portable GFCI. For appliances, we're really worried about these 2 here, the GFCI receptacle and the GFCI circuit breaker. And it's important to note the pricing difference, because we're going to talk about electrical codes and why electrical codes have changed over the years to make it so that more GFCIs are required in the home. And it's important to understand the pricing difference to understand that. So if we go to Home Depot's website today and try and purchase a 20 amp, 120 volt, single pole, standard trip circuit breaker, it's going to run us about $7. If we go to Home Depot's website and try to purchase that same circuit breaker with the same specifications, but GFCI trip, it runs us about 4 times the cost there. So something to keep in mind when we're talking about electrical codes here. How does a GFCI work? So despite its name and that the first letter is G for ground, the GFCI has nothing to do with the ground conductor. The GFCI does not measure current to ground. When we look at inside a GFCI, it's this dotted line here. This is everything that's inside the GFCI breaker or inside the GFCI receptacle. And we can see the ground, that's normally the one with green insulation, that's the bottom pin on your standard plug, is just a pass-through. The ground is passing through the GFCI. No measurements are taken on it. Nothing is done with the grounding conductor. What the GFCI is doing is measuring a differential current. It's taking a current clamp, just a donut, around your hot and neutral conductors and measuring the difference in current between your hot and neutral conductors. And the GFCI is assuming that that difference in current between the hot and neutral conductors is being passed to ground. And if it's being passed to ground, that means that maybe a consumer can come in contact with that current. So if that differential current is high enough, it could mean that there's something hazardous going on. There's a hazardous current to ground. So something to keep in mind, GFCIs are not measuring on the ground conductor. They're measuring a differential current. When must a GFCI trip? So these are the GFCI trip requirements that are in place today. And GFCI trip requirements are governed by UL 943. That is the UL standard for the GFCI, whether it's a GFCI breaker or a GFCI receptacle, they all have to comply with these requirements. And something to keep in mind before we look at this diagram is that the electricity coming out of the wall in North America is at a frequency of 60 hertz. So it makes sense that all the GFCI trip requirements are at 60 hertz. If a GFCI measures a 60 hertz differential current of 4 milliamps or less, it shall not trip. In order to get its UL approval, it cannot trip. UL will give it some signals at less than 4 milliamps. And if it trips at less than 4 milliamps or less, then it's no good. It cannot get UL 943 certification. If a GFCI senses a 60 hertz differential current between 4 milliamps and 6 milliamps, the GFCI may trip. It's up to the individual GFCI manufacturer to decide that. If the GFCI sees that signal of 6 milliamps or greater, it has to trip. It must trip in order to comply with that UL standard. So we're going to come back to those GFCI trip requirements, but we also want to talk about where our GFCI is required to be installed in a home. And this is where we bring in the national electrical codes and local electrical codes. So the answer to that question, unfortunately, is not simple. The answer is it depends. It depends where you are. The requirements are dictated by the local electrical code. So where are GFCIs required to be installed in the home? Well, it's wherever the local electrical code says that they're required. So the local electrical code in most cases is a state. There's a state electrical code. It can also be counties and cities. So for example, Illinois and Arizona, they don't have a statewide electrical code. It's left up to counties and cities. New York City, Mobile, Alabama have their own electrical codes, for example. In most cases, the entire state has an electrical code. So how does this local electrical code get made? Well, it's built from two components. First is the National Electrical Code, and the NEC is just a document. It's not issued by the government. It's just a piece of paper issued by an organization, and it comes out every 3 years. So right now, these are the versions, these are the versions of the National Electrical Code that are being used. There are still some places using the 2008 NEC as part of their local electrical code. There are some places that are using the latest 2023 NEC as part of their local electrical code. And then we have local amendments. So what a state, county, or city will do is they will adopt an addition of the NEC and they will make changes. So for example, one of the changes they could make is requiring less GFCIs than the NEC. At this point, most states don't have that. Most states have just accepted what is in the National Electrical Code for GFCIs, but we'll talk about some states that have. So that's a little bit of background on where the GFCI is required to be installed in the home. And there are 3 paragraphs in electrical codes that lay out the requirements for where a GFCI is required. 210.8A, 210.8D, and 422.5A. So these are available for free online, whether it's the National Electrical Code or your local electrical code. And these are written in layman's terms. You don't have to be an electrician, an electrical engineer to understand these. This is the numbers you want to look for in your local electrical code or the National Electrical Code when you're trying to find the GFCI requirements. A little more detail on where our GFCI is required to be installed in a home. So we've seen significant changes in how to answer this question over the past few years. If we start by looking at the 2017 NEC, which is effective in about 15 states right now, we see that GFCIs focus on places like bathrooms, kitchen countertops, those kinds of places. Then in the 2020 NEC, because of a really big push from GFCI manufacturers, we see that GFCIs are being required in not just 120 volt circuits, but also on 240 volt circuits. So if you live in a state that state electrical code has adopted the 2020 NEC without GFCI amendments, you now have to connect, for example, wall ovens, dryers, 240 volt air conditioners to GFCIs if they're in certain locations. Then in the 2023 NEC, again, a push from GFCI manufacturers to expand the requirements to install these devices. We see probably the biggest expansion is kitchens. So if your state has adopted the 2023 NEC without amendments, everywhere in the kitchen, every receptacle in the kitchen must be GFCI protected. So your oven, your microwave, all your countertop appliances must be connected to either that GFCI receptacle or a regular receptacle that feeds back to a GFCI breaker. So this is a big change, and I think this is a lot of the root cause that's causing heartburn out there today for new constructions. So it doesn't end there. It's a little bit more complex. There's another section of electrical codes that require GFCIs for certain appliances. So it doesn't matter where these things are in the house. They must be connected to a GFCI. So in 2020, we saw dishwashers added. They must be connected to a GFCI no matter where they are in the house, according to the 2020 NEC. And then in the 2023 NEC, we see a major expansion. So no matter where you have an electric range in the house, no matter where you have a microwave oven in the house, a clothes dryer, according to the 2023 NEC, it must be connected to a GFCI. So again, this is a big push from the GFCI manufacturers. They have a lot of power when it comes to the electrical codes. We as appliance manufacturers tried to fight against that, but we just didn't have the votes. We didn't have the voice, unfortunately, to change that. Okay, so that's kind of the national level about where are GFCIs required. There are some states that are taking action on this. There are states that have walked back GFCI installation requirements due to nuisance tripping. And we'll get into exactly what nuisance tripping means on the next slide. Massachusetts is a great example. 1,000+ cases of nuisance tripping in a very short period of time in Massachusetts. So these are folks who did not have access to their kitchen appliances, did not have access to their air conditioning appliances, their ranges, their refrigerators would not turn on. Safe, brand new appliances would not turn on because the GFCI kept tripping. So Massachusetts has acted and has now changed their electrical code to say, if you are nuisance tripping, you can go ahead and take out the GFCI. Oregon has done something similar. They've done something a little bit more proactive, where they've also seen cases of nuisance tripping. And they've said for your major appliances that aren't going to be moved, you're probably not going to have water splashing on the receptacle behind them, for example. You don't need a GFCI. You don't even need to install one in the first place. So there are some states that are taking action on this issue. All right, so what is nuisance tripping? Nuisance tripping is the tripping of the GFCI during normal appliance operation where power is cut off to the appliance and the appliance ceases to operate without warning. And there are a ton of nuisance tripping cases going on across the country, whether it be Massachusetts, Oregon, Texas, virtually every major appliance brand we represent has indicated that this is a big, big problem. So let's start to talk about why is this happening? Why is nuisance tripping occurring? Well, we can look at the development cycle of GFCIs versus the development cycle of appliances. So GFCIs first introduced in the 1960s, first become required in 1971. And between 1971 and today, GFCIs really haven't changed. Those same GFCIs that were used in the past to protect hair dryers and blenders and toasters in bathrooms and kitchen countertops are now being used today to protect much more complex appliances, things like refrigerators, microwaves, induction cooktops. So GFCIs have not been modernized over the years. Appliances, on the other hand, have been modernized. As you all know, appliances have changed a lot to meet consumer features that are being asked for by consumers, but appliances are also required to modernize by law. When you buy an appliance or you're installing an appliance, you see that yellow sticker on the front that says Energy Guide. That's part of the Energy Policy Act and previous energy acts that have been in place for decades from our federal government. Appliances, about every 7 years, are required to get more efficient in order to be put in the marketplace. So a refrigerator that gets sold in the year 2000 has a certain efficiency, and then a refrigerator that gets sold in the year 2007 has to meet a more stringent efficiency level. So appliances have certainly changed over the years, whereas GFCIs have not. So what does that mean, appliances have not? Well, appliances have incorporated new types of components. And these components don't just operate at 60 hertz. They operate at frequencies above 60 hertz. So we're taking 60 hertz out of the wall, and then in appliances, that 60 hertz electricity is being turned into other frequencies of electricity. So some examples of components that do that are variable speed drives, whether that be a compressor, a fan, or a pump, a switch mode power supply, and LED drivers. All of these components are operating on frequencies higher than 60 hertz. The issue here is that there are no GFCI trip requirements for those higher frequencies. So we have this giant gray area here that is untested. It is up to each GFCI manufacturer to decide where they will and will not trip. And we have safe, normal operation of modern appliances in this gray area. So that's a big issue because GFCIs can trip all the way down here, even if it's safe. There's no UL requirement telling them they shall not trip. And we have proof of this. So each GFCI manufacturer decides their own trip levels at frequencies greater than 60 hertz. We just talked about that. And this graph proves that. This is test data. Each different color line is a different model of GFCI. And there's a few things we notice about this graph. This graph shows trip current versus frequency. So for example, this gray star here means this model, manufacturer 3 model 1, at around 500 hertz is tripping at about 100 milliamps. When it senses, when that donut senses about 100 milliamps, it's tripping at 500 hertz. So a few other things about this graph. We see a nice clump here. All the different GFCI models at 60 hertz are tripping in that same band. That's great. We want them all to be condensed so we know what to expect in the field. As appliance designers, we want to know how the GFCI is going to perform in the field, and seeing something like this is great because we know what to design around. Appliance designers do. So the reason this big clump is here is because the UL standard requires it. At 60 hertz, you have to trip between these levels and you shall not trip below certain levels. The problem with this graph is all of this in the red circle. The non-standardized high frequency trip thresholds that GFCI manufacturers are putting out there today. The big issue here is that these trip levels are happening on safe levels of electricity. So this green block is actually drawn conservatively. If I was really scientific about it, it would be a curve going up like this. But all of these points in the green block, these are safe electrical signals proven by third-party studies, and there is no reason for the GFCI to be tripping down here. But the GFCIs are tripping down here, down at, this is 5.5 milliamps. No danger here to a consumer, but we have GFCIs tripping down here. because they can, because the UL 943 standard says, that's okay. The UL 943 standard is agnostic to those high frequency. And you don't have to take my word for it. So there's multiple third parties that have also investigated this and come to the same conclusion. Inconsistency in GFCI trip levels causes nuisance tripping. CPSC, the Product Safety Commission from our federal government, has looked into this and issued a public letter noting that electrical noise causes nuisance tripping of ground fault circuit interrupters. Underwriters Laboratories has conducted a compatibility study without any funding from the appliance industry. This was self-funded by UL. They took 3 different appliances from 3 different manufacturers, connected them to 10 GFCIs, and GFCIs nuisance tripped on all 3 of those appliances. All of those appliances were confirmed to be operating in a safe way by UL, by any measurement you can think of, but GFCIs tripped on all of those appliances. And this is the link. And again, I'll give my slides to UASA, but this is the link where you can read more about the study if you're interested. Okay. So summary here, why is nuisance tripping happening? There is an intersection of safe, normal operation, high frequency appliance leakage currents, and these random high frequency GFCI trip thresholds. So those 2 things should not be intersected. If the appliance is safe, the GFCI should not be tripping. All right, most important part, nuisance tripping resolution. How can you all fix nuisance tripping when it happens? So unfortunately, there's no quick fixes. There is a technological incompatibility between appliances and GFCIs right now. GFCIs need to be modernized. And there's also a role appliance manufacturers can play in making sure that they don't have that high frequency noise and making sure that that high frequency noise is safe. So we'll walk through 3 different kinds of resolutions: short-term resolutions, medium-term, and long-term. I think probably the #1 solution I hear from electricians is trying a different brand of GFCI. If you're having trouble with a Siemens, put in an Eaton, for example. So we'll go through in detail some of these short-term resolutions. We'll talk about medium-term. Always a good idea to call the appliance manufacturer, call the GFCI manufacturer, hear it from the source. They may have solutions that they can give you. We'll also talk about how to talk to electricians and electrical inspectors to solve this problem, some sources that you can give them and direction that you can give them to help. And we'll also talk about long-term resolutions. There are ways that you all, appliance servicers, can get involved in electrical codes and change them to make your jobs easier. And I'll give some details on that as well. So let's start with the short-term resolutions. How do I know if the GFCI is nuisance tripping or it's a safety issue? So you can do your normal inspection of an appliance for shorts to ground. So if you see things like nicks in the wiring, nicks in the coating, motor windings, pitting, or of course any arcing, those could be indications of shorts to ground, and that's a safety issue. So of course, something's wrong with the appliance there. The GFCI is just doing this job. It's not nuisance tripping in that case. You can check if the appliance has a variable speed drive. So for it to be nuisance tripping, it doesn't have to have a variable speed drive, but a variable speed drive, from what we've seen, makes it more likely to be nuisance tripping. So you can check the component list or just check the information online for that model, see if it has a variable speed drive. Another thing, a quick test you can do is you can connect the appliance to a non-GFCI outlet with a GFCI extension cord. And you want to make sure the extension cord is suitable. Proper wire gauge, you're not plugging it in while it's around the reel so the extension cord melts, all that stuff. Make sure you're using the extension cord in a suitable way. Let's use the example of a refrigerator. Let's say the refrigerator is plugged into a receptacle that is protected by a GFCI breaker. And that GFCI breaker keeps nuisance tripping. And you've done your inspection on the refrigerator. Everything is fine. It's operating safely. You can unplug that refrigerator, plug in a GFCI extension cord and plug it into a receptacle in a hallway. And you want to check the breaker box just to make sure that that hallway receptacle isn't also connected to a GFCI. A lot of times it's not. And then you can just do a little test and see if that original GFCI is tripping, but the GFCI extension cord that you've now replaced that original GFCI with is not tripping. That probably means that that original GFCI breaker is nuisance tripping. That probably means there's nothing wrong with the appliance and something that GFCI breaker is tripping when it shouldn't. So that's a quick test that you can do. Another short-term resolution. Check if a GFCI is actually required. If not, replace it with a non-GFCI. And this is something you can do in 10 minutes. You don't have to be an electrician. You don't have to be an electrical engineer. You don't have to be a code official to do this. So in most cases, the state dictates the edition of the NEC used. So step one, find out which edition of the NEC is used in your state. And I'm going to use Georgia as an example. So I can just Google Georgia Electrical Code NEC. And we get a Georgia government link. I forget if it's the first or second link. We click on it. We see that Georgia is using the 2020 NEC. Then we can read these 3 paragraphs. They're short in layman's terms, 210.8A, 210.8D, and 422.5A of the National Electrical Code edition. So I can Google free access NEC. And within the first few links, I can click that link and select the 2020 NEC because in my previous Google search, I saw that Georgia is using the 2020 NEC. Step 3, check if the state has amendments to those 3 sections of the NEC. So simple Google search here, Georgia Electrical Code NEC amendments. And within the first few links, we can confirm that Georgia does amend the NEC when it comes to GFCIs. The state of Georgia has taken action to make sure that nuisance tripping doesn't occur. So just to better explain that, here's a screenshot from the 2020 NEC, which says that all 125 volt through 250 volt receptacles are required to be connected to a GFCI. Then we have the state amendment that takes out this through 250 volt part. It just says all 120 volt receptacles are required to be connected to a GFCI. So if you've got a dryer, a wall oven, a 240 volt air conditioner in Georgia that is nuisance tripping on a GFCI, you can go ahead and just take it out. Take out the GFCI, put in a regular receptacle, a regular circuit breaker. You're still within state code. And I see we have a question in the chat. Samuel said, does this relate to arc fault as well or just GFCI? Samuel, most of this presentation is going to cover GFCI, but we are going to touch on AFCI at the end a little bit, and I'm happy to take AFCI questions as well at the end of this. All right. So another short-term solution to GFCI nuisance tripping is to move the receptacle to a location that does not require a GFCI. So for example, if you have a receptacle that's within 6 feet of a sink that's connected to a GFCI breaker, you can remove that receptacle just 2 feet down the wall, work with an electrician to do that if you're not qualified yourself. And then that GFCI that receptacle is no longer required to be GFCI protected. Another thing you can do is create a dedicated circuit for the appliance. So we'll use the 2020 NEC and a refrigerator as an example here. You may have a kitchen counter receptacle that is a GFCI, and that's because kitchen counters have been required to have GFCI protection for years and years. And you may see a refrigerator on that same circuit. So, and then you'll see this GFCI nuisance tripping whenever, for example, the refrigerator's compressor kicks on. One of the things you can do and recommend to an electrician as a fix is put this refrigerator on a dedicated circuit. So remove it from this branch circuit and feed wires directly from the refrigerator receptacle back to the breaker panel. In that case, it does not have to be a GFCI. So you can avoid the GFCI requirement by creating that dedicated circuit. When you're talking to an electrician, you can point out, hey, this is more work for you, and it is allowed to 210.8A of the NEC. So that's another short-term fix. The last short-term fix we'll go over is hardwiring the appliance. The location-based GFCI requirements in the NEC only apply to receptacles. Let's step through an example. Let's say you have a cord-connected washing machine in a basement that is nuisance tripping. And again, we'll use the 2020 NEC as an example because that's what's most widely used today. The 2020 NEC requires that all basement receptacles be GFCI protected. So both of these installations are allowed as per the 2020 NEC. So this may be an installation that you had nuisance tripping on, cord connection with a GFCI breaker. So the wires from this receptacle feed back through the walls into the breaker panel and come to a GFCI breaker. Well, that doesn't have to be the installation. There's another installation that the National Electrical Code allows, and that is a hardwiring. So you can hardwire that washing machine into a junction box, and then that GFCI breaker can be replaced with a standard breaker. And that is completely allowed by the 2020 National Electrical Code. Of course, you want to make sure that's okay with the appliance manufacturer. Give their service line a call, give your service rep an email, and shoot them the question, hey, is it okay if I hardwire this appliance? So that's another short-term resolution. Medium term. So these are other resolutions you maybe can't enact as quickly. If those short-term resolutions aren't working for you, these are other things that can help. Contact the manufacturers. We talked about this earlier, both appliance and GFCI. There are some cases where appliance manufacturers can supply you a modification kit or a procedure. For example, you run an oven using this procedure and that makes it less prone to nuisance tripping. Or they can send you a modification kit to plug in. That's some cases. And in some cases, maybe the more responsible GFCI manufacturers will send you an updated model with their latest firmware and software that isn't as sensitive. So these are the service phone numbers for the major GFCI manufacturers. I know there's some here that are less responsive than others, but it doesn't hurt to give them a call. Another medium-term resolution is you can ask the electrical inspector in your area to roll back to the most recent previous version of the NEC. Okay, so the National Electrical Code states that this code may require new products that may not yet be available at the time this code is adopted. In such event, the authority having jurisdiction, that means the electrical inspector, may permit constructions that comply with the most recent previous edition. So let's walk through an example to understand that. Let's say we have a refrigerator in a finished area of a basement that is nuisance tripping. So according to the 2020 NEC, that refrigerator has to be GFCI protected. But what we can do is we can go to the local electrical inspector and we can say, there are a lack of available modernized GFCIs. There are new products that are not yet available. These old GFCIs have not been updated. And you can use an AHAM white paper, which I'm going to make available to UASA. And I'll also give you the PDF of that UL study. So you can hand the electrical inspector our white paper and the UL study and say, listen, there are new products that are not yet available, new GFCIs that are not yet available. So in those cases, we can go back to the most recent previous version of the code. So because the current version of the code is the 2020 NEC in our example, we can roll back to the 2017 NEC, an older version of the code that does not require a GFCI on this installation. So I know that's not the fastest solution. You have to get a hold of your local electrical inspector, but this is something the code allows, and you can get in touch with them to get permission to do this. Another medium-term solution is home appliance manufacturers aren't just sitting by and letting this GFCI expansion happen. We have submitted a proposal to the 2023 National Electrical Code seeking tentative interim amendments. These are like emergency changes to the electrical code. And so we're looking to roll back GFCI requirements for refrigerators and HVAC appliances, also ranges, ovens, cooktops, and microwave ovens. And these are proposals that we've made to the National Electrical Code body that oversees all of this. And appliance service providers can participate in these proposals. You can engage in the electrical code process, make sure that the NEC is practical and also considers the safety risks of losing appliance operation. So if I were to ask anything from you all today, this is one way in which you all can help yourselves with GFCI nuisance tripping. So that you can submit a public comment today, right now, through September 6th, I believe, to get a change in the National Electrical Code. There's a few steps to doing it. You can draft an email to this email address, and it has to have this subject line. It's very specific. And then you're going to want to put this sentence in the body of the email. This is a public comment on the AHAM proposals, TIA 1748 and 1749. And you have to say you support these proposals to walk back GFCI requirements. And then in the body of the email, you want to include some kind of rationale on why you support these proposals. And these are the texts of these proposals if you want to go back at the recording or the slides and read through them. And your rationale can be simple as GFCI nuisance tripping has been a problem for my organization. The code must be fixed to prevent nuisance tripping. You can also cite cases. You know, I had a whole apartment building, a whole housing development where the washing machines didn't work, for example, or the refrigerators didn't. So this is a great way for your voice to be heard and actually get GFCIs rolled back in the electrical code. So this is one way that you can definitely help your organization avoid these cases. Of course, appliance manufacturers are going to be doing this as well, but it helps for the electrical code bodies to hear it from multiple stakeholders, not just from appliance manufacturers, but also from those boots on the ground, you all who are actually directly dealing with it. Your comments are going to have a big impact on changing electrical codes. So this is one way to do that. The long-term resolution. So this is doesn't totally pertain to your everyday work, but this is something that you should be aware of. They are working on updating the requirements in the UL standard, UL 943. So they are working on updating those requirements. So rather than all this gray area that we saw here, we want to better define those requirements for high frequencies. So this is the solution for updated GFCI specifications. We see this green zone expanded. It's not just this skinny little bar at 60 hertz, but the GFCI shall not trip if it's safe at 60 hertz or any other frequency. So if you have a variable speed drive or an LED driver operating in this range, the GFCI shall not trip. And I would expect GFCIs to be updated maybe in the 2028, 2029 timeframe. It's going to be a while for them to update their products and manufacturing lines, but that is being worked. And of course, another long-term resolution is that electrical codes must roll back GFCI requirements. GFCI manufacturers pushed that expansion through prematurely, and they really have a lot of incentive to dominate the electrical code process, and they've been very successful in doing that. So there are ways you can get involved and have an official vote in electrical codes at the national level, and I'd be happy to help any of you get involved in that. My email here will be at the end of the presentation. You can also report GFCI nuisance tripping. It doesn't directly help your situation, but it does help long-term. So you can report GFCI nuisance tripping to us. You can use this QR code that'll take you to our form. Takes 5 minutes to fill out. We'll pass that on to the end product manufacturer. Of course, you can report it directly to the end product manufacturer as well. So reporting, hearing about these cases is important, because when you talk to GFCI manufacturers and you say, hey, we need to roll back these NEC requirements, they'll say, nuisance tripping isn't happening. You're making this up. This is the appliance's fault. When we know, according to the UL study and testing that's been done, that's just not true. Okay. So let's talk quickly about AFCIs. AFCIs are arc fault circuit interrupters, and AFCIs are very different from GFCIs. AFCI's purpose is to prevent electrical fires, not electrical shock. And in a lot of cases, you'll see AFCIs implemented in a circuit breaker form. In almost all cases, it's implemented in a circuit breaker form. And you'll see it bundled with a GFCI. So you'll see a single breaker that does AFCI and GFCI protection. There are AFCI receptacles on the market, but they're very rare. So AFCIs is in an even worse state than the GFCI, unfortunately. So the AFCI doesn't have a set measurement that it has to trip. When we looked at the GFCI, we saw that it has to trip on a measurement, some kind of measurement related to ground current. Well, for AFCIs, each AFCI manufacturer can choose their trip criteria and their trip measurements. So if one AFCI manufacturer wants to make their trip requirements based on voltage, they can do that. If another AFCI manufacturer wants to make their trip requirements based on current, they can do that. Both are allowed. The big problem here is that AFCI manufacturers don't make their trip thresholds public. So what happens today when nuisance tripping on AFCIs occurs? A home appliance manufacturer, let's say they want to release a new product or a new technology. That home appliance manufacturer then has to sign a contract with each AFCI manufacturer and get a non-disclosure agreement in place. Then each AFCI manufacturer provides their trip thresholds to each appliance manufacturer. Then the appliance manufacturer has to update their products to avoid each AFCI manufacturer's trip thresholds. That is so inefficient, and that's the present state today, unfortunately. The worst part about that is because it's not defined in the UL standard. These are just recommendations from AFCI manufacturers. Those can change all the time. So if a home appliance manufacturer contacts an AFCI manufacturer and we get those trip thresholds, they could change a day later and still be compliant with the UL standard. So we're working on updating the UL AFCI standard. Of course, we're getting resistance from AFCI manufacturers, but we're trying to get to the ideal state where there's a consensus standard that's open to everybody, that defines exactly when an AFCI must trip, and then home appliance manufacturers can use those standards to avoid those trip levels. Some good news on AFCIs is we have not seen AFCI expansion in the electrical codes recently. In the 2023 NEC, we saw no expansion of AFCI. So when it comes to AFCIs, the 2020 NEC and the 2023 NEC are in alignment. And it's the reason AFCI manufacturers weren't able to achieve that expansion are because of these reasons. Electricians, home builders, home appliance manufacturers have shouted at the top of the mountains that AFCIs are not working. So we've been successful in not getting AFCIs expanded in the latest electrical code. Other good news here is a lot of states, I think we're at 23 states and significant cities, have walked back AFCI requirements. So they've made those local amendments to say, you know, the NEC has gone too far and we are walking back those AFCI requirements. So states, when they hear about problems, they do react, and we're seeing that with AFCIs especially. Okay, so that's a lot of information on GFCIs and AFCIs brought your way. So I do want to leave some time for questions, and I'll give my email here at the end. So any questions from you all, any thoughts or comments from you all, would love to hear them.
Great. Your brain is huge, man. That was amazing. I appreciate all those details. Started taking notes and my hand cramped up. So I'm looking forward to the slides. This is going to have a huge impact with my technicians and educating them and helping them. This is one of those nuisance service calls for us, isn't it?
Yeah, and unfortunately, you all as appliance servicers end up apologizing for something that's not your fault. This has nothing to do with any work that you've done. So these slides are white paper. You're welcome to give that to customers. It's written pretty much in layman's terms. So appreciate that comment, Doug. And you definitely all will get the slides in writing. So hopefully that'll help. Any other questions, comments here?
I just want to say thank you for allowing it to be recorded, because in addition to the slides, it's just really valuable for somebody to sit down and watch this for continuing education.
Absolutely, Jenny. Thanks for that. So from my side, thanks, Maxine. If you want to pass on the recording or any of the materials we give you to anybody, whether it be your customers or electricians or electrical inspectors, you are welcome to do that. There's no embargo on passing on this material. This is open information for you to share with whoever you want.
Awesome presentation, Greg.
Thanks,
looks like
Michael.
Lance was asking about going over the extension cord process.
Absolutely. Yeah, so that's a little complex. So good question, Lance. Okay, so let's assume we have a refrigerator that is installed like this. Let's just look at this oval. The refrigerator is plugged into a receptacle, and that receptacle goes back to a GFCI circuit breaker. We know these GFCI circuit breakers can be very sensitive. They can trip on safe levels of electrical signals. So what can we do about that to see if it's nuisance tripping or not? This is one way we can diagnose it. We can unplug the refrigerator from this receptacle here. Oops, sorry. We can unplug this, and we can plug this male end into the female end of a GFCI extension cord. Then we plug the male end of the GFCI extension cord into a regular outlet that is not a GFCI outlet, and it is not connected to a GFCI circuit. So then you can compare the performance of your original GFCI circuit breaker that it was originally connected to and your GFCI extension cord. So if the original GFCI is tripping, that GFCI circuit breaker, but that GFCI extension cord is not tripping, that probably means that the original GFCI, your GFCI circuit breaker, is nuisance tripping. So that means that there's a problem with this device. It's tripping on something it shouldn't be. So that's one way you can diagnose to see if it is nuisance tripping. And it doesn't, if both are nuisance tripping, if both are tripping, it could still be nuisance tripping. So that doesn't rule anything out. But the one thing this does tell you, if the circuit breaker is tripping, but this is not tripping, that means there's something wrong with the breaker.
Hey, Greg, quick question for you. Who regulates the little part in the extension cord for the GFCI? I mean, because you could go out and buy a random brand, and it's like the graph that you showed, different manufacturers have different set points or trip points.
Great point, Michael. So you're right. So the GFCI extension cord could also be faulty, right? It could also be tripping at these very low levels of safe electrical signals. So the only way this process really helps you is if the breaker is tripping, but this is not tripping, right? That means one of them is more sensitive than the other. They both meet UL requirements. So Michael, that's a great point. Just because your extension cord is tripping, it could still be nuisance tripping. Your refrigerator could still be safe. Okay, so appreciate that clarification.
So variable speed evaporator fan motors, are you suggesting they can be causing a nuisance trip?
Totally, yes. So variable speed fans, pumps, compressors, they're operating safely, but they're not operating, they're operating at high frequencies, which today there's no GFCI requirements for that. So your a vat motor on for your fan is probably safe. But if you do have a variable speed fan, compressor, pump, that makes it more likely to be nuisance tripping, because those components are generating high frequency electricity that the GFCI is not required to account for today.
Greg, another question for you. So you're definitely not recommending putting a extension cord on it that's rated for the appliance and go to a non-GFI outlet directly. I mean, we've done that for years to prove to the customer that there's an issue, you know, so you're not recommending that now?
So are you suggesting that as a long-term fix, or just something to prove to the customer that it's not the appliance?
Just something to prove to the customer so that we can back it up to tell them to call an electrician, because I'm sure there's a whole consortium of technicians here that'll tell you how many times a technician has referred the customer to an electrician, and an electrician come out and say, no, the appliance repairman's full of crap. And then the next thing you know, they want their bill paid and everything else. So that's what we just basically do, just to prove that there's an issue.
So I would recommend that. I'm sorry if I confused it earlier, Michael. That is a good process to plug it into a non-GFCI breaker, even just using a regular extension cord to prove the point. I think that's fine, as long as it's not being left long term. That's a good idea to prove nuisance tripping.
All right, thank you.
Mm-hmm.
Anybody else? Okay. Oh,
So just last thing, I'll put my email up on the screen, and it's going to be, this is going to be on the slides, so you don't have to write down this long last name here. And you all are welcome to email me if you have questions, or if you want to get involved in code development and make sure your voice is heard. There is absolutely room to do that. If you need help on how to talk to an electrician, or you've got some negative feedback for electrician, let me know, and I can give you the material to help you out there. So I'm here as a resource to help you folks.
thank you, Greg. We appreciate your support, and we appreciate you coming on today and facilitating this and helping our members and educating everyone.
Appreciate the time. Thank you all so much
Thank you.
for attending.
All right, thank you.
Anyone else? Oh, sorry, go ahead.
I just said, thank you, Greg.
You're welcome.
And if anyone has any questions or needs anything else, please feel free to reach out to Greg directly, or feel free to email me or Maggie, or call us, and we will get you in touch with Greg. Thank you again, everybody, and have a great afternoon.
Will you be
Thanks, folks.
automatically sending out the slides to the attendees, or do we need to request them?
We'll be posting them on our website. Once Greg's gonna send them to us, we're gonna put them on our website, and we'll post them there. So we'll send out a link through social media as well as email, letting people know that the webinar, or the laundry room, is up under our webinars, and that the slides are up as well.
Perfect. Thank you so much.
Thank you. Awesome. Have a great day, everybody. Thank you.